All right, so a few more topics on this particular handout. So here's the example of, similar to what we just tried. We just tried the short version of it, and then you can specify formats. Just remember that you need to call the get instance for the date format, and the date format works with dates. Uh, More custom formats can be produced by using the calendar, and this is what we did earlier on with this type of work, right? So you can call the get methods to extract individual parts of the calendar and do it this way. So one more thing here. Gregorian calendar formatting example. Same thing, like we said before, uh, you create the calendar instance, then you extract the date, and then you go and use date format if you wanted to. So this is another situation where you can just copy and paste and just you know spare yourself some time typing it in. But it's when you do this over and over and over again, over time you basically learn how to do this, and it becomes kind of natural. Because at the beginning, if you're just starting your project and trying to work with dates on the calendar and date format, at times you feel like lost. That we really want our answers quickly. What is the best way for me to create the calendar and then insert the printout someplace? So it's just remember that you can use date format, but in order to use date format, you have to go to a date first from the calendar, and that's just a typical thing. So this is how we specify everything, and then date usage example. Okay, date usage demo. All right, so let's take a look at this. All right, so apparently there's here's an example of a class that's trying to use date. Okay, fine. So it says get current date and get formatted date. So formatted date returns a string, and of course it's using the date format, using the specific style for the resulting date, and uses format to generate the string. So that's uh, an example of typical code that you find in a class that's using date. I'm not sure why it says invoice date. I just don't know. But it's trying to be more generic demo, but it is what it is. So here's something quite useful, DateUtils. Let me actually create this. Control C, I will copy the name of the class, and I'd suggest that you should probably have this utility class somewhere in your own library of classes, unless your team already has a library of utility classes like this. But normally, it's convenient to go here and say, so let me just create a new Java class, and I'll name it DateUtils, just like that. Same package, so I'll push it through, and I will just copy and paste. I'll copy and paste the code. So this is my DateUtils right there. Right, so this is my class. And so what I propose that you keep in mind is that you can have let me just paste the content of this class, and we can examine it in our source editor right here. So hopefully none of it is going to appear new. So let's just say source format. And then, of course, we need to say fix imports, and let's just do our imports. review our reports quickly. So yes, use utility for the calendar, the date, and Gregorian calendar. And so let's take a look at the code. So here's that milliseconds in a day constant that is also available here. We can, if you think it may be usable elsewhere, you can make it public. There's nothing wrong with making a constant value like this one is. And I think for the sake of convenience, this better be a long, because if you use it with long computations, you may as well declare it long, just to remind ourselves that this is a, it may be used in computations for long. So, DateUtils, here, get current date. So, what it does is that it gives you the date, but look what it does. First of all, it creates the Gregorian calendar first with using default constructor, which creates the current date and time internally. But then, see what it does? It populates hour, minute, and second fields with zeros. So once it does that, it essentially removes the time component. So the time is set to 0, and this is in many situations you want to avoid doing some extra computations with the Gregorian calendar or with the date, where you want to just wipe off the time component. You just want to be able to point to a specific date, which may improve accuracy of your differences or comparisons of particular date and time. So it's not uncommon to create the date essentially with the time pieces eliminated. And this demonstrates how it can be done. Okay, obviously, when you have this calendar object, you return the date from it by saying get time. And instead of saying get date, it tells you get time. Another one returns the date for a specified date. So you want to construct a date object for a specific year, month, and day. Remember, the date, unlike Gregorian calendar, does not have a constructor for year, month, and day. You really have to convert everything to this Unix epoch milliseconds in order to be able to use a specific constructor with date. So once again, just construct Gregorian calendar for the year, month, and day, and just say get time, and it returns back a date. Now notice that once you call something a utility class, it is expected that your methods inside this class are static, which means that nothing requires instantiation of the utils class. Just methods can be called directly by using the class name. So perhaps we can, if I now display it side by side, just like this, maybe we can manage to write some demo code with this. So we can say DateUtils. We can give this another try right here with the today thing. We can say, instead of saying new date, we could have said DateUtils DateUtils get current, or I can just simply make myself a little bit more space here and just copy and paste. Create date, that's what I meant to do. Create date, and I'll just specify year, which would be 2015. Month will be February, and the day is 10. Okay, and then Um, Here I think that if I run this, save everything, and then run it. Let's see. Um, I think in that sample we have a small little bug, which, like I told you, requires testing and testing and more testing. Um, when I pass this value, see what comes back. It comes back as March 10, 2015. And this is due to the fact that what I need to do is subtract 1 from the month. Because when you deal with Gregorian calendar, remember you have to use zero-based month, right? So I was basically looking at this and thinking, am I thinking it different or not? And clearly this sample has a bug, so I need to update that web page with that sample. So this is much more like it, right? And notice that when you use Gregorian calendar and when you do not populate the fields responsible for the time components, look what comes back, 12 a.m. So everything is like to set to 0 hour, 0 minute, and 0 second, and which is visualizable as 12 a.m. Okay. Likewise, in many cases, you want to avoid storing this kind of like almost random current time component. So you can eliminate, you can say strip time, remove time pieces from a date instance by, and once again, the easiest way to do this, so it's like you have a date but you want to strip the time component from it. So it refers to 12 a.m., the beginning of the calendar date. So look what happens. We construct the Gregorian calendar. We set its information to the date that was passed, and then we eliminate the current date hour and second. And so we could even call this method right here. Um, um, Actually, no. This is where we do take the date in and we convert to another date. I was thinking about other method, but this is just a returns date without the time component, which was removed. So those could be very useful utilities when you do your programming. You see, if you have a database and you'd like to store some values of dates in there, and you decided to store those long integers that represent your date, you may as well want to strip the time piece of it and to keep it clean, just to keep it as 12 a.m. rather than every time a random time component to that value. So it's just is typically very useful. And there's your, we already had a slide that showed you the date difference, computation. Now we kind of like formulated this, formalized it as a method implementation. And so what it does, it takes two dates, date 1 and date 2, and converts everything to milliseconds, does division by milliseconds in a day, and compute the difference. This one is returning an integer also. It's like there's another interesting part to it, is that sometimes the difference, you really don't want long, but you want an integer. So clearly we can cast to an integer because we know that the long is divided and the result is the long integer, but you can cast it to an integer by using the cast operator here with an integer type specified in front. So these are, I think, are very useful utilities. And if you try programming, with date, times, and in general calendar aspects of date and time, you get this uh, convenience of using the Gregorian calendar and the date class, and of course the date format. But still, there is still plenty of space for custom programming here, so just the way we did it today.